Hi everyone. As you can see, I'm just about to start my daily routine inspection, checking if everything is in a good condition. You might remember that we want to see some fresh grease oozing out of the bearings. That way you can tell that your central lubrication system is working. You know, lubrication is a very essential issue. But let me introduce you to someone who can tell you more about this subject. Hello, Lubert.
Hi.
I was just talking about the central lubrication system. Can you tell us what makes it so important?
Okay. Bearing and shaft are both made of metal. But metal grinding on metal without proper lubrication will produce premature wear and tear. As everybody knows, grease is used to reduce friction. This is because its molecular structure is that of a cluster of balls.
So, we use grease to reduce friction between surfaces. But won't there be a difference in the way grease flows out of the bearings in hot climates compared to cold climates?
Ah, good question. We do have different lubricants for different climates. Of course, while in motion, part of the grease is squeezed out of the bearing, so the grease has to be replenished regularly. In the old days, it was done manually. But with an excavator like this method would not be practical.
Sounds like no fun at all.
Indeed. With monsters like this one, moving so much weight at such high speeds, replenishing intervals are very short due to the load on the bearings.
And that's where the central lubrication system comes in.
Exactly. Home sweet home. The central lubrication system.
So, how does this work?
The principle is fairly easy to understand. You take a pump, connect the input to the grease depot and the output to the changeover valve. The changeover valve has two main line outputs, line A and line B. The two lines feed various so-called grease distributors. The distributors come in different sizes and can supply several bearings with grease. You need enough distributors to feed all the bearings on the excavator. At the beginning of a greasing cycle, you start pumping and grease is pressed into the changeover valve, which first supplies grease into line A. The plungers in the distributors start to walk to one side, and grease is supplied to all bearings on one side of the machine. And that's how it looks on the machine. The pump sits on top of the grease tank. The primary distribution is handled via the control panel. There are two separate grease lines, line A and line B. They each serve one side of the excavator. This is the changeover valve. The grease from the pump arrives here. This gauge shows the pressure of the grease, which is distributed via the changeover valve, one line at a time. This solenoid switches between the lines. You keep pumping for a certain time, 2 minutes, until you are sure all plunges have moved to the one side. Then you stop pumping and do the same for line B.
Sounds good enough. Great.
One should think so. And in fact, this is a method used even in older models of this excavator. But there are two setbacks. There's no feedback. You never know if the grease actually reaches the target. What if a line is broken? Also, the whole system relies on preset times. When the pump is active, the pressure just keeps building up. This will somewhat reduce the lifespan of the pump.
So, that's what makes a daily routine inspection so important.
That's one major reason.
And what in the newer models has changed concerning the central lubrication system?
In principle, easy to explain. Now, there's feedback built in, represented by these two proximity switches, as well as a smarter PLC. So now, when the first cycle starts, we can see by the feedback from the proximity switch that the plunges have moved to the one direction.
Okay, so the proximity switches indicate that the plunges on this specific distributor have moved. But what about all the other distributors?
Good question. You are right. The proximity switches do only indicate the position of the one plunger in this distributor. For this reason, we did mount the switches to a distributor that is far away from the pump. Therefore, it is most likely that the distributors that are closer to the grease pump have already shifted.
And what happens with the distributors behind the one with the proximity switches?
Hey Hank, I have the feeling you are becoming an expert on grease systems. As soon as the proximity switch detects the movement of the plunger, the timer starts ticking. Then grease is pumped for an additional 22 seconds into the line. To make sure also that the distributors behind the one with the proximity switch receive enough grease. It's clear that the pump didn't have to work that long and the pressure in the system did not build up so high. The pump won't wear out so fast. Also, we can now check if the grease reaches its destination.
I understand. You reduce the load on the pump as you now stop pumping 22 seconds after the proximity switches are activated. But what happens in the wintertime?
Well, my friend, the first thing you want to do is prepare for the cold. A good time before you run into the risk of experiencing cold weather, you prepare for it by changing your grease to a proper winter grease. This winter grease has a different viscosity in order to be able to push through the narrow cold lines.
So, it's all about preventative maintenance. You actually need to change your grease according to the upcoming season in enough time before you run into the risk of temperature changes.
That's it. Now you must also think about the time it takes to push the existing grease product out of all the lines and have them completely filled with the product that fits the season. Grease that has just left the pump may take up to 2 weeks to finally arrive at the bucket.
Okay, I will remind my maintenance crew to change the grease with enough time before the seasons change.
Hey, good idea. But today's system has one more safety feature built in to ensure the grease reaches all the distributors.
Alright, but could you explain this to me in the summertime? I'm starting to freeze.
No worries, mate.
Ah, that's it.
You may have noticed the pressure sensor on the panel?
I guess it reads the grease pressure of the system.
That's right. Today's system not only relies on the 2 proximity switches on the stick. The pump continues to pump grease into the lines until the proximity switches are activated and the pressure has reached 250 bar.
Wow. So we do not only rely on switches. Now I feel more comfortable. What is this line for?
That's a solenoid for the undercarriage grease pump. It's an optional feature, so you won't find it on every excavator, but it has proven to be quite useful. Also, we have an additional feature to lubricate the teeth of the slew ring.
Thanks a lot. I think you've given everybody a good idea of how the automatic lubrication system works and what it's good for.
Anytime. Y'all take care.
You might think nowadays, with everything being highly automated, an inspection tool would be unnecessary. But it's not. You are the first in line when it comes to spotting trouble with your machine. And your eyes and your ears are still the most valuable tools in fulfilling this task. You know your machine, you know what it sounds like, how it's supposed to behave, and how everything looks. So, if anything's abnormal, you would be the first to know. Ultimately, you are responsible for keeping this beauty up and running for the longest time possible. See you around. Bye everyone.